In part, this is a science film. In part, this is a proposal from me to you for dramatically changing the world. Mostly, this is all extremely interesting. It explains truly life-changing breakthroughs in physics, and a special topic that deals with water, droughts, famine, and the planet's environment. Altogether, this film covers three main topics: the solution to the question, what is time? The grand unification of physics, and the solution to fusion energy. In my opinion, directly and indirectly, this new physics is going to dramatically change your life. One very interesting, very specific benefit of this new physics is it will enable us to collect massive amounts of fresh water in hot deserts. Obviously, a benefit like that would greatly help to eliminate droughts and famines. In essence, this new physics is very green. Again, at one time, Lake Chad was about this big, but we don't really want to refill the ancient lake to this level. Because its southern rim has collapsed, it would be impossible anyhow. However, this land, the blue in this image, could become green. The Lake Chad Basin could become a lush, green, wet, fertile land. Much of the ancient life that once lived in this ancient lake still creates tremendous amounts of fertility in the soil of this region. If nothing is done, this ancient sediment will just keep blowing away in massive dust storms. If desert grasses are grown here, this fertility can be retained. That should be our first goal. We want to restore the Lake Chad Basin with desert grasses and savannas. Obviously, some of the land will be transformed into farmland. We want to help the local people. If half of this basin is farmed, it would completely change Africa. The horrible famines would end. This would be terraforming. You would think NASA should be interested in a project like this. Over the years, they have studied terraforming Mars. Let me put it this way. If we can't terraform here on Earth, then why would we expect that we could do it on some other planet? Terraforming a portion of the Sahara Desert would give great insights into what it takes to terraform another planet. Obviously, there are many potential problems for a project like this. Obviously, nature can give you problems with things like massive dust storms or plagues of locusts. Obviously, people can give you problems with things like politics, bandits, armed conflicts, or wars. How would success be determined? I understand that would be somewhat ambiguous. If the study area's sterile desert sands could be mostly covered with green desert grasses for at least one full year, then that would be a major success. If the desert sand can be improved to the point where it develops a layer of topsoil, a layer that would also allow things like insects, worms, and healthy microorganisms to survive, then that would be another major success. Being able to grow trees and crops, reestablishing towns in the area, getting the Delia River to start flowing from the Termit Mountains, there are many ways success could be measured. Personally, I would love to see Lake Chad refilling. That would be exciting. It would also be really great to see Africa's great animals rediscover the area and then to watch them as they move back into the area. Personally, I'm very interested in testing techniques for reestablishing soil, bioorganisms, techniques for transforming the desert sands into healthy soil. Techniques like the ancient terra preta technique, where you mix charcoal into the sands, or many of the modern techniques like where you mix mass-produced algae into the sands. To recap, in the first phase I would simply like to green a section of the Niger Desert to the northwest of Lake Chad. Later in the experiment, if things are going well, I would start phase 2. In phase 2, I would place more dogs in other locations around the lake. Each new dog would be close enough to support the existing area that has already been greened. From space, this would look like an area of green life is growing its way across the Sahara Desert, gradually reclaiming the desert. If mankind does not do this artificially, I estimate it'll take another 4,000 to 5,000 years before the next cycle of greening will transform the Sahara naturally. The Sahara will become wet and green again naturally. But why wait? This experiment could be expanded. There are other great locations to the west and northwest in Niger and to the northeast of Lake Chad, in Chad. The topography of this entire mega Lake Chad basin is low. In essence, it forms a huge depression, a huge basin. Let me talk about one particular area in this basin, a specific area in the country of Chad. This is a very interesting location. It is called the Bodell Depression. It is the darker red area in this image. Again, these topographical images are from the Space Shuttle's SRTM mission. And again, I've compressed the colors to emphasize the elevations. Red is low, green is high. First, this area is roughly southeast of Bilma, a small town in Niger. Second, it is south of Faya-Largeau, a town in Chad. I apologize, I'm not certain on pronunciations. Third, it lies to the northeast of Lake Chad. The Bodell Depression's elevation is very low, lower than the water level of Lake Chad itself. At this time, the water level elevation of Lake Chad is about 282 meters above sea level. The lowest areas of the Bodell Depression are about 122 meters lower. Its lowest point is only about 160 meters above sea level. But this value is constantly changing due to the shifting height of the sand dunes in the area. You might think, because the Bodell Depression is so much lower and so close to Lake Chad, the water from Lake Chad should completely drain into this lower basin. Notice the ancient dried up riverbed between them. Right now, Lake Chad's water can't flow downhill because in between them there's a large natural dam made from drifting sand dunes. Again, this entire area was once part of Mega Lake Chad. This entire area forms a giant basin. The Bodell Depression is the lowest area within this basin. It once was the deepest part of Mega Lake Chad. As Mega Lake Chad dried up, it left behind massive amounts of dried up sediments. This includes fine calcium from freshwater shells. Now, the almost unending strong winds from the northeast can easily whip this ancient sediment into the atmosphere, creating gigantic dust storms. The Bodell is so dry, it typically has no rain in a year. Instead, every year it experiences about 100 days with major dust storms. The sediment from the old lake is simply blowing away in the wind. The Bodell Depression is sometimes called the dustiest location on Earth. These sand and dust storms scour the desert, leaving long lines that stretch for hundreds of miles. Interestingly, the Bodell Depression is now the source of most of the dust in the Earth's atmosphere. This affects global warming. One study estimated that 40 million tons of African dust is transported from this location to the Amazon jungle basin in Brazil, clear across the Atlantic Ocean every year. 40 million tons of dust make it from here to the Amazon every year. I find that amazing. This is quite a contrast from 7,000 years ago, when the Bodell Depression was 170 meters beneath one of the largest lakes in the history of the world, or when it was 300 meters beneath the largest lake in the history of the world. We don't know when that was, but it may have been as long as 1 to 3 million years ago. Again, if Lake Chad once flowed east and really was the original headwater of the Nile River, then the bottom of the Bodell Depression was once about 300 meters below the largest lake in the history of the world. Again, the massive 3-mile wide riverbed that flowed east from Lake Chad is now at a height of about 460 to 463 meters above sea level. Back when the lake was full, this height would have been lower, but so would have been the bottom of the Bodell Depression. If the bottom of the Bodell Depression is now 160 meters above sea level, when the lake was full, that weight would have compressed the Earth's crust down the most at this deepest point. In my opinion, the Bodell Depression is the linchpin to greening the entire Sahara, or at least to greening at least 60% of the Sahara. The Bodell Depression will be exceptionally difficult to green. There's no doubt dust storms will block progress. In my opinion, the simplest strategy would be to grow a thin layer of desert grasses in this depression. This would stabilize the ancient powdery sediments and dramatically reduce the dust storms. After that, the eastern flank looks promising for farm crops. The desert grasses would be minimal but widespread. The grasses would stabilize the soil. These grasses don't even need to be green over the entire year. Maybe every 4 to 6 months, the desert grasses could be briefly irrigated to bring them out of hibernation. Then the grasses would grow again and spread their roots. This would put a halt to the majority of the dust storms. Imagine what it'd be like if this area had only 1 or 2 major dust storms per year instead of 100. That would be a significant improvement.